Let's now look at some exam questions regarding normal distribution. The first one is this question 2 from spring 2014, paper 61. Lengths of a certain type of white radish are normally distributed with mean mu centimeters and standard deviation sigma centimeters. 4% of these radishes are longer than 12 centimeters and 32% are longer than 9 centimeters. Find the median and the standard deviation. Okay, so what are we given? We are given already some probabilities which are made in terms of the length of white radish, which is basically our random variable. And we have here the probability for x to be bigger than 12 and for x to be bigger than 9. We are going to use the corresponding z-values to establish two equations, simultaneous equations, that will give us the value of the mean and the standard deviation. Two unknowns, you need two equations, right? So basically this is normal distribution with these two parameters. And if the probability of x being bigger than 12 is 0.04, we calculate this by doing 1 minus the probability that x is smaller than 12. To be more precise, is smaller or equal, but in this context it doesn't matter. It's going to matter next lesson, as you're going to see. All right, so this is 1 minus the phi of 12 minus the median over the standard deviation, the things that we want to know, okay? So this means that this alone is going to be 1 minus 0.04, that is 0.96. So you already have here the probability, and you are going to use the table, this table, to work it back. The probability was 0.94. Let's try to find it over here. 0.94 is over here. So this is 0.9394 at 6, and you have 0.94. So this corresponds to 1.555. Let's go there. Okay, no, I got 1.751. Let me see again. 0.96. Of course, it's over here. 0.9599, so you just need to add 0.0001, this over here. So we are basically looking at 1.751. 1.751, that's what I wrote over there. Okay, let's do exactly the same thing, but now instead of 12 using 9. So the procedure is basically the same. Looking again on the table, we will get this z value. And these are the two equations that you are going to set up in the form of simultaneous equations to get the values of mu and sigma. I use substitution. You should know this for a long time. And here you have the two values. Next question is from winter 2013, paper 61. I particularly like this question because it's very conceptual. It says, it is given that x can be modeled by a normal distribution with parameters 30, 49, y can be modeled by the normal distribution with parameters 30, 16, and z can be modeled by the normal distribution with parameters 50, 16. On a single diagram with the horizontal axis going from 0 to 70, sketch three curves to represent the distributions of x, y, and z. If you look, x and y, they have one thing in common and one thing different. The thing in common is the mean. They have the same mean, all right? But they have different standard deviations, okay? Here, the standard deviation is going to be square root of 49. Here, the standard deviation is going to be square root of 16. Don't forget that the parameter that you have over here is the variance, okay? And the square and the standard deviation is the square root of the variance. If you now compare y and z, they will have the same standard deviation or variance. What is going to change now is the position of the mean. All right? So having this in consideration, what are you going to have? You are going to have this. See? X and Y. I already put here the values that are important. Let's compare first X and Y. X and Y, they have the same mean, which is 30. Okay? So it's over here. They peak at the same value, right? And then the bell curve is going to be symmetric to the left and the right of this dotted line. The thing is that the height of curve Y is going to be bigger than the height of curve X. And why is that? The reason is that the area of any bell curve has to be equal to 1. Okay? So if this one is narrower because the standard deviation is smaller, I'm talking about Y, and don't forget that it almost touches the horizontal axis when you have a standard deviation that goes close to 3 times the value of the standard deviation, so in this case 12. So in this case it would be 30 minus 12, it would be 18. From 18 to 42, okay? Whereas in this case, it will be the standard deviation is 7, so 3 times that is going to be 21. 30 minus 21, that's basically 9. And the 30 plus 21, that's going to be 51, all right? So you have here the scale. So both these areas for X and Y, or for all standard deviations for that matter, they need to be equal to 1. So because this one is narrower, has to be taller than X, right? I have here this dotted line. I don't know what corresponds to. I'm just going to take it out. Yeah, okay. Let me just save that. Okay, so now we are comparing Y and Z. And I didn't write the here. Okay, so here I have Z. Let me save it again. So what is the difference here? The standard deviation is going to be the same. So the range of these two positions of the bell curve is going to be basically the same. This curve is exactly the same one as that one. The only thing that changes is the position of the median. This one is on 30, this one is on 50. See, by looking at this, analyzing these curves and looking at the information that you are given, you will most definitely understand everything that there is to know about the normal distribution. Let's move on. We were on this one, now it's paper 6 from November what? November 2007. Question 4. You have this diagram and it says that the random variable x has a normal distribution with mean 4.5. It is given that the probability that x is bigger than 5.5 is this, and you have to find the standard deviation of x. You should know how to solve this already, okay? I reproduced here the diagram. You know that the probability of x being bigger than a value equals 1 minus the probability of x being smaller or equal to that value, okay? To get this part in specific, you use the value minus the median divided by the standard deviation, and that's the thing that you want, okay? You know that this basically is 1. So you know that this over here equals 0.0463, sorry. So the value of the phi of the z value is 1 minus that, which is this value over here. Now you go to the table and find this probability, okay? It's going to be 1.68. So we're looking at 0.9535. 0.9535. Here it is. 9535, so that is 1.68. Here it is. So the sigma, the standard deviation, is 1 over that, and here it is. Now you have all the parameters needed to calculate anything else, which in this case is the probability that a random observation of x lies between 3.8 and 4.8. So this is equal to the probability that x is smaller than 4.8 minus the probability that x is smaller than 3.8. Just use a standard procedure. You'll have a positive z-value, a negative z-value. Don't forget that this is calculated using 1 minus the probability of finding the corresponding positive z-value. Then work this out. Minus and minus is just plus. So get the z-value table to get these probabilities. Don't forget to subtract that one over there. And here you have it. There are 2 more questions for us to solve. This is from 2009, paper 61, and is question 3. The times for a certain car journey have a normal distribution with mean 100 minutes and standard deviation 7 minutes. Journey times are classified as follows. Short for the shortest 33% of times, long for the longest 33% of times, and standard the remaining 34% of times. Find the probability that the randomly chosen car journey takes between 85 and 100 minutes. While you have all the information needed, you have the mean and the standard deviation. So that's all that you need. Let me just get there. Okay, it's the same question as before. Okay, one of the, just for curiosity, this value over here, 100, is exactly the mean. So that's the probability. It's obviously 0.5. This z-value is going to be negative, so don't forget to do 1 minus the phi of the positive z-value. Use the table and you get the result. Okay, there's nothing new about this particular sub-question. Let's see the other one. Find the least and greatest times for standard journeys. What are standard journeys again? The remaining 34% of times. With a diagram, you'll understand this better. Okay, I did it over here. This over here, this area over here is a probability that the journey is a short journey. This over here is a probability that the journey is a long journey. These horizontal bars correspond to the probability that it is a standard journey. Okay, so if it is a standard journey and you have 34% of chances of it being a standard journey, it means that out of these 34%, 17%, half of 34, must be to the right of the mean, and 17% must be to the left of the mean. Right? So basically, if here to the left of the mean you have 50%, 50% plus 17%, that's 67%. This limit over here corresponds, or better yet, the area to this limit over here, the area to the left, corresponds to 67% of chances. Make sense? Again, this area is 34. You know that it is, you have equal areas to the left and the right of the median. So if the whole thing is 34, you have 17 for each side, right? The median is the position that divides the bell curve into equal 50% sides, right? So all of this is 50%, all of that is 50%. If this is 50% and this bit over here is 17, so this whole area over here is going to be 67%, right? So the phi of the value that you want, the t minus the mean, which is 100, divided by the standard deviation, is going to be equal to 0.67%. So you go to the table, find the z-value corresponding to 0.67%. I already did that, and for 0.67%, that's 0.44. 0.44 is 67%, as you can see here. And now that you know the z-value, you calculate t. And the t is 103.1 minutes. This is the greatest. Okay? So let's look at the question again. The least and the greatest times. We just found the greatest time, that is 103.1 minutes. If the median is 100, this over here is 3.1 minutes. So what is going to be this value over here? Is going to be 100 minus 3.1 minutes, right? This should be 1, okay? So that's going to be 96.9 minutes. Actually, this wasn't supposed to be 1. The true value is 3.08. I just rounded here to 1 decimal place. So that this is correct. Anyway, the least value is 96.9 minutes.